this video, we are going to quickly review transformer transients. Basically, transients are a short-lived burst of energy in a system which is caused by a sudden change of state. So for this particular diagram, we can see there is a transient that is due to the sudden change in state of the system. In case of transformer, if there is change in current, voltage or frequency, and it should be the sudden change, so there is possibility of transient in transformer between its initial and final steady state. One thing should be remembered, that these transients are of short duration which has certain detrimental effect. It is responsible for breakdown of transformer insulation. There is possibility of deformation of winding and overheating of transformer due to transients. The transients can be classified into overcurrent and overvoltage transients. Our focus would be on overcurrent transient. In particular, this case, basically the overcurrent transients occur in transformer whenever there is unloaded transformer is switched on or the secondary is short circuited. So let us see what is the switching in phenomena or inverse phenomena which is occur due to the overcurrent transient. So overcurrent transient means the switching on of unloaded transformer. An unloaded transformer, when its secondary is open, or we can say there is no load at that time, it is going to behave like an inductor, and inductor has a property that its current cannot suddenly change, basically, or we can say the flux that is not going to be changed suddenly. So this defines basically the constant flux linkage theorem. So according to that, if the flux before the closing the switch is some value, so it has to remain that value after closing of the switch. So the value of the flux it is not going to change at t is equal to 0 plus and t is equal to 0 minus. We know that in case of transformer, the flux that lags voltage by 90 degrees. So our transformer that can be switched on at any instant between this instant 1 and instant 2, it can be switched on somewhere. Either it can switch on at instant 1, it can be switched on between these two values, at instant 2. So what happened if it is going to switch on at a particular instant? Suppose in between this instant 1 and instant 2, instant 1 we could observe that the voltage is 0 and the flux has negative maximum. At instant 2, voltage has maximum value and the flux has 0 value. And suppose your transformer is going to switch on in between somewhere, so the value of the voltage is this one, so corresponding value of the flux which will be demanded by the transformer, that would be this much. So whenever the transformer is going to switch on at this condition, so the voltage, the applied voltage would be the V1, and actually at that time what would be the value of the flux at T0 minus. So at T0 minus, the value of the flux that will be 0, and immediately after closing the switch, the value of the flux, it must remain 0. But at this time we could see from this particular diagram that the transformer is going to demand this value of the flux. We can consider, suppose it is a phi r phi m, so it is going to demand. But in order to follow the constant flux linkage theorem, that flux that must remain the same, that is 0 in this particular case. So the transformer is going to produce a flux which is called as the DC flux, and the value of the DC flux that would be equal to this value the instant when the transformer is going to be turned on. So that particular value of the flux is going to be basically generated, produced by the transformer, and that value would remain constant if the R1 is neglected, that is the primary leakage resistance is neglected. So that is shown in this particular figure. We have seen at this instant the transformer is going to turn on, so it is going to demand this particular value of the flux, and as at this time at t is equal to 0 minus, the value of the flux is 0, so at t is equal to 0 plus, the flux must remain 0, so the transformer is producing this flux, and this is going to remain constant. Now there are two fluxes in transformer. One is your constant DC flux, another one is alternating flux, so both are going to contribute. So the resultant flux that will be given by this particular value, this particular diagram. This the maximum value of the resultant flux, that would be equal to 5 dc plus 5 m. There could be another instant when the transformer could be turned on. It could be this instant. At this instant, what is happening? Instant number one, the voltage is 0, and we could see the flux has certain value. So when voltage is 0, so what would be the value of the flux? It would be certain value. That would be 0, and after switching on, the value would be 0. But here the value which is demanded, that would be quite the negative maximum value. So it has to generate this particular value, that is the phi m. It must be produced by the transformer. So ultimately it would be like this only, and the resultant flux, that will be given by basically the phi dc minus phi m cos omega t. So in this case, what would happen? There is at omega t is equal to 180 degree, the flux that would the resultant flux which is due to your DC flux and the alternating flux, it would be double. So doubling effect would be there. If your transformer is going to turn on at this particular instant, so what would happen? That we could see that the value of the flux is 0 here, and when the transformer is switched on, the value of voltage, that is maximum, but the value of the flux is 0. So at this particular instant, it is going to demand the value of flux 0. So there will be no transient. So this is the behavior of particular transient in case of transformer. Thank you for watching video. If you want to if you are having any questions, query, you can drop into the comment box. Thank you very much.